In algebra, one of the things we have to understand is if we're dealing with a function or if not a function. So what is a function? What is it all about? You're going to learn that in this video. Let's get started. In this video, I'm going to teach you all about functions and how we look at a relation and determine whether or not that is or is not a function. So let's take a peek at the definition. Function: for every input, there can only be
one output, only one output.
Better get that stuck in your brain, because that's the question to ask every single time. No matter what mathematical representation I give to you.
Whether it's a graph, mapping diagram, list of ordered pairs, table of values.
Doesn't matter what the math looks like, you need to be able to look at the X values, the inputs, the domain, whatever you want to call it. We're going to go over all that terminology in this video so that you have a strong understanding of it. And then ask yourself this question: does every input only have
one output?
I'm going to show you tricks for each and every mathematical representation provided, and then you're going to be a function magician by the end of this video. Let's get started. We're going to start with tables. Here we are. Sweet, look at those tables. One of them is a function, one of them is not. Can you spot the one that is? Well, all we have to do is ask ourselves which one of these has only one output for every single one of its inputs. The best way to do a table of values is just look at your X column. These are your inputs. The Y's are your outputs. These are your inputs. The Y's are your outputs. If you see a repeated value in the X's only worry about the X's. So do I see a repeated value? I go -2. Does -2 pop up again? No, it does not. Does 0 pop up again? No, it does not. Does 2 pop up again? No, it does not. And 4 is only up there one time. So if you look at this table, we have no repeated X values. That is almost automatically going to guarantee that this is a function and this one over here is not. Which one over here causes this to not be a function? So we got our function here. Hopefully you're looking and reviewing this one over here and trying to spot the value that causes this table to not be a function. So we've got one here. We do not have a function here. This is not a function. And the reason it is not a function is because you have already found it, haven't you? Nice job out there. It's these, the 5s. 5's producing a 3, 5 is also producing a 4. 5 can't produce more than one value. In this case, it's producing a 3 as well as a 4, so it's producing 2 outputs, but functions can only produce 1. Hopefully that makes sense. Let's move on to the next one, mapping diagrams. Whoa, those are mapping diagrams. Mapping diagrams are just like a table of values, except we connect the Y value to the X value through an arrow. So we just draw an arrow saying that this input connects to that output. Those arrows can go up, they can go down, straight across. Doesn't matter what direction the arrow is going. Really all you're focusing on is, do I have 2 arrows coming off of the X values? So if I'm looking at these, one of them is a function, one of them is not. Can you spot the one that is not? Remember, the way to figure out if something is not a function in a mapping diagram is just, do I have an X value that has more than one arrow pointing off of it? So let's take a peek. One arrow, one arrow, one arrow, one arrow. Oh, that must be a function. And then over here, can you tell me which one of these values for X causes it to not be a function? Hopefully the one you're thinking about is 8. If you look at 8, we have an arrow going straight to 10. So this is saying 8 will produce a 10, but 8 will also produce a 7 in this scenario. This relation is not a function because 8 is producing more than one output. Hopefully that makes sense. Let's move on to graphs. Look at those graphs. All right, so we got to determine which one of these is a function, which one of these is not a function. How do we determine that on a graph? Again, for every input, there can only be one output. Our inputs are our X values, so all these numbers going across the X-axis. So inputs, all these values. Outputs are the Y values that you get. The graph is the easiest one, in my opinion, to determine if it is or is not a function, because you can do it very quickly by just drawing the vertical line test. Vertical line test means if you draw a vertical line, see how many times that vertical line you drew hits. It marks right there. It only hits in one spot. Therefore, let's just say we're at 1, 2, 3, 4, 5. The input of 5 is only producing one output value right there. Okay, same goes for right here. If I were to draw a vertical line right here, I only hit one time, so the input of 1 is only producing one output. Now on this first one, or excuse me, over here, so this is a function. But on this first one over here that I have to the left, If I were to draw a vertical line, notice that I'm gonna hit more than one time. I'm gonna hit right there as well as right here. So if that was the input of 2, 2 is producing an output there as well as an output up there. So this is not a function because the input of 2 has more than one output. So with the input of 3, it's gonna go do-do-do-do-do-do-do-do-do-do. Boom, marked right there, boom, marked right there. So to connect this to our tables, right, X, Y, if I were to produce this on a table, I'd have a 2 and another 2 with different values, maybe up here at 3, and then another one up here at 20. So I'd have something like that, which remember, we already practiced tables. If you have repeated values for X with different values for Y, we're dealing with not a function. So there's graphs for you. And last but not least, we have to look at a list of ordered pairs. So here's a beautiful list drawn up for you now. And here we have a list of ordered pairs. So we got A separated to B. When one of these relations is a function, one of them is not. So how do we determine that? Does every input have exactly one output? Best way to do it with a list of ordered pairs is just simply look at those X values. I got a 6, I got a 4, I got a 6. Ooh. Remember when we were talking about tables, when we were talking about mapping diagrams, we were looking for repeated X values. It's all about the X value. Does that X value repeat more than one time? If it does, and it produces different outputs, not a function. So right here, I got 6 producing a 7, but over here, I also have a 6 producing a 2. So the input of 6 has one output, the input of 6 has a second output, making this not a function. And the whole reason this one is not a function is just because of the 6. The input of 6 is producing more than one output. So not a function. Over here, all I got to look at is my X values. 2, 3, 4, 5. You did not hear me say the same number twice, so there was no repeated X values. Therefore, this is a function. Now you can now you can determine if something is a function or if it is not a function, whether it is a list of ordered pairs. If it's a graph, just draw a vertical line, see if it hits more than one time. If it's a table of values, you're looking for repeated numbers for X's, just like you are on a list of ordered pairs. And then mapping diagrams, you can just look at the arrows and see if more than one arrow goes off of the X side. If that's the case, if you have more than one arrow going off the X side, not a function. If you have repeated X values with different Y values, not a function. If you draw a vertical line and it hits more than one time, not a function. If those things do not occur, no repeats for X's, only one arrow going off of the mapping diagrams, and if you draw a vertical line and it only hits once, those are all examples of functions. Hopefully this makes sense. Study hard and good luck on your upcoming test.